And hello, good afternoon. Thank you for joining me. I'm really excited to be here and share with you a little bit of the work that I've been doing in the space in making. So with that, I'll just get started. So as Michael said, I consider myself an accessibility researcher, and I approach everything from a human-centered computing lens, which really means I really focus first on who the user is, and then I start thinking about what are the opportunities to match technology to that. One thing that I like to kind of do when I'm starting out explaining my approach to research, and one thing when I'm considering about accessibility research, is that accessibility and thinking about what are the opportunities for technology is a lot more complex than just matching somebody's ability or a diagnosis to some kind of technology that could magically overcome or fix this. And I draw a lot from disability theory that looks at kind of the medical and social models of disability. If you have questions, I can talk about that later. So in addition to understanding an individual's ability, I spend a lot of my time working to understand specific populations or individuals' habits and preferences, and use all of that information when I'm thinking about what are opportunities or challenges for technology. And this really impacts the methodology that I use in my research. The first one is user collaboration. So many of you have probably been hearing about participatory design as a method that you can use where you invite your user group into your design team. I like this image that shows one of my PhD students, Michelle Williams, designing a wearable piece of technology with a woman who's blind. You can tell it's just a clipboard on some string, but it's really powerful in terms of talking about what the opportunities and challenges might be about neck-worn displays or technologies. The other thing that I really incorporate into everything that I do, and I was talking a little bit about this at lunch with the PhD students, is really thinking about longitudinal field work. I'm going to today highlight a bunch of different groups that I've worked with, and every one of them has a story that's usually a pretty long one where I go there, make connections, get to know the organization, and then involve them in research, which is a little bit different from some other kinds of HCI research where you're able to go off and send out a recruitment email and then just have a whole bunch of people show up. So it's a bit more work. And this is something that I've been doing for a long time. This actually is an image of United Cerebral Palsy Center in Pittsburgh, where I spent many days a week as a PhD student, both volunteering and doing long-term observations. And so I do all of this work in my research lab, which is called the PAD, which is a prototyping and design lab, where we have a bunch of different kinds of digital fabrication tools. We build stuff in there. It's a space to be noisy, space to be messy. But if you go there on any given day, you're probably not going to find a lot of students there because most of the time we're out in the field. That's where we go to our participants rather than bringing them into our messy, chaotic space. So today I'm going to talk about a couple of different things. I want to start by talking about the vision and the opportunity that I see for the DIY and the larger maker movement to revolutionize accessibility and specifically assistive technologies. I'll talk about my initial vision and work that I had done to kind of evaluate the feasibility of that vision, and tell you about some of the things that aren't so great about that vision. And then I'll switch gears, and in the making accessible component, tell you a little bit about some of the tools and training efforts that we're doing to really help broaden the group of people who are involved in making. And then my favorite part is always so what did you learn? I have a lot of recommendations and suggestions from all this work that I've been doing for the past several years. All right, so the first one is talking about opportunity. So if any of you have taken or are about to take any kind of assistive technology class, you will learn pretty quickly that assistive technologies are really, really broad. And many of us in this room are actually using assistive technologies right now, right? So many of us are wearing lenses that are able to correct our vision, that are able to help us see more. Sometimes there's very traditional assistive technologies, things that you can buy in medical catalogs, things that come from a prescription and covered by insurance. But then we're also seeing people use other kinds of technologies, such as these kinds of games, or there were like Wii bowling leagues for a while as ways to get people to exercise, that are more kind of reappropriating technologies and objects that are in the world and using them as assistive technologies. So I just wanted to call out that I think of a very broad approach to assistive technology, where it's anything that you're using to then let you do something you couldn't do otherwise. So it sounds great, right? Like, I've called out a bunch of assistive technologies. Some of us are using them. Other ones you've probably heard about, seen, you know people who are using them. Like, we're done here, right? Assistive technologies help people do things. The end, right? Like, that shortest talk ever. No. But there's this huge problem. So even though like lots of people have worked to solve the engineering problem, figuring out how to make a technology that meets the ability need, it turns out that a lot of people don't actually use the assistive technologies that they have for them. And there's a whole world of people who study the abandonment rates of assistive technologies. I like this one study that has a number that's about 30% of assistive technologies that people end up on the shelf. But if you look in the breakdowns of which different populations they are for or what activities they are for, you can see abandonment numbers range from like 8% all the way up to 75%. And the highest numbers are usually with things that are around hearing aids, because people don't like the perception of looking disabled. So there's a whole bunch of theory there if you're interested. But what I found really interesting is looking at, well, what are the reasons that these abandonment researchers say are why people are not using the technology? And it's that it's that their habits and their preferences really are the things that are being overlooked. People are more focusing only on ability. So I think this is where DIY comes into play, where doing it yourself offers the opportunity for people to have more customization, get things faster, have things be more affordable, and this could impact the abandonment rates. So I want to talk through just like a couple of those concepts and hopefully try and convince you why there's so much opportunity for DIY to really help with this. The first one that might be the most obvious is the speed, right? So if you're doing it yourself, you're doing the design work, you're doing the fabrication, then you're in control of the amount of time it's going to take for you to get it. If you're someone who's getting a power wheelchair, that can take like a year from when you initially are recommended to have a new power wheelchair from when it's in your house. So that's a long time. Also, if you're doing it yourself, you can be testing it at home or in your favorite coffee shop or whatever your context of daily life is, rather than at this specific clinic where everybody's watching you and they're really like, yes, this better work, you'd better like it, because it took us forever to get it here and it was really expensive. The other thing is that doing it yourself can be very appealing because you might not have to interact as much with insurance. A lot of assistive technologies, the way people get them is actually through a prescription that then gets approved by insurance and then goes out to bid and then goes out to, and it just, this whole timeline, there's a lot of people involved. There's a lot of things that can go wrong. So it's very appealing to have it be faster. Also, doing it yourself is appealing because it can be very customizable. If you really want to have the thing be pink, you can make it pink, right? You can really design things to fit in with your daily life, within the other objects or technologies in your life. This is an image that I really like to also illustrate this, of an exoskeleton for a young girl that's made out of like 3D printed parts and rubber bands. And so if you're thinking about designing technology for people whose abilities are constantly changing, fast turnaround and customization for what do they need today can be really, really important. And finally, do-it-yourself can be super affordable. Yes, there are these catalogs. I love this example of a cup holder that attaches to a wheelchair for $110. You could go to your favorite hardware store and buy the same materials for a couple of dollars. And when we're talking about, you know, resource-constrained populations, price is really attractive. Finally, doing it yourself is really empowering. This maker movement has been very popular in the past few years. I would say that even is coming out or alongside, the popularity of HGTV, people cooking more, Martha Stewart, right? Like, people are really proud of things that they make. Some of us wear scarves that maybe aren't very well crafted, but we made it ourselves, or someone we love made it, and so we're willing to wear it. We're excited to use it. This can also be very empowering for people who might be used to receiving things, going shopping or ordering things through catalogs and really not having much control. And this idea of that can be really empowering. And in terms of this and motivating it, this came from some initial interviews that I was doing, and I found this quote that someone said of, when it breaks, I stay in bed, to be very powerful. And the idea of being able to control, if you're able to go outside by changing some things, having some control over your assistive technologies is really important. So I just want to call out, this idea of doing it yourself is not new at all. Anthropologists have documented early humans using animal horns up to their ear to amplify sound. Or there's a long history of people having some kind of foot or leg injury, making crutches out of materials that are around. Or Therese Wilcombe, who's known as kind of the MacGyver of assistive technology, knows every kind of tape and every kind of clay to make any kind of grip that you ever want. But there is something fundamental that's changed within the last 10 or so years that I want to talk about, and that is these new maker tools and maker communities that have been developed. So oftentimes, if I were to give this talk 15 years ago and I were to talk about making tools, you might think about tools like this. But these tools are not very accessible. They make a lot of assumptions about ability. They're making assumptions that you're able to remember different kinds of steps to use this safely. You have some kind of specifics about vision, that you're able to see details, you're able to see or hear lights or sounds come on, and motor abilities. And as a result, a lot of people are not able to use these kinds of traditional making tools. And you can contrast that to this new generation of tools that I generally call digital fabrication tools, that then, if you can access a computer, you can do most of the work in terms of fabricating the physical object. And I think this is really, really exciting. Within this ecosystem of different tools, I feel that 3D printers are the easiest for people to use and probably make the fewest assumptions about the end user, because theoretically, for the most part, if you're able to, slice your model and hit print at whatever stage, and then it goes, you can then get it off the plate. Where laser cutters, you need to worry about fires, CNC mills, there's a lot of things. So I focus on 3D printers because I think they're the easiest for people to get started with. And 3D printers are now everywhere. I love that Costco was selling Dremel 3D printers with, manufacturer rebates. Amazon has a whole bunch of 3D printers that we could probably get here in an hour for under a few $100s. If you can't or don't want to have one of these in your home, there are lots of places that you can go and have objects made for you. Tech Shop or other kinds of maker gyms where you have a subscription and then you have access to tools, but they don't need to be in your home. Or what I think is really exciting is business models like Shapeways, where you can create a file, send it off, and then have it mailed to you. And if you think again about physical accessibility or assumptions about users, that's all computer access, right? If I can use my computer and do the design and send my file, it'll come to me in the mail. And that can be really exciting and really accessible. So along with all of these physical tools, or these tools that can make these physical objects, there's been also a huge change in terms of people sharing things that they were made. And this coincides with lots of things that people are doing online, where they're sharing things that they did, ideas that they had. People are collaboratively working together to solve problems online. And many people in this room are studying these online communities or thinking about other ways to support these activities. But I think it's really important here, where you might not know anybody in your area with your same ability, but you could imagine networking with them and finding them online and sharing resources so you both can share some kind of new tool. Yeah, Michael.
Implicit in what you're stating here is that the individuals who need this support, the computational tools or the mobile web or whatever, are sufficiently accessible to them. I'm wondering, of the individuals who need the support, what percentage of them can actually use these things that you're talking about?
What an amazing question. So I did this kind of analysis of the stage and was starting to figure out like how much people would want to participate. And that led me to the study that we did in 2014, 2015 to figure out who was actually doing this and why. So I'm going to tell you about a study that we did. It was a systematic review of things that were on Thingiverse. So show of hands, who here has ever heard of Thingiverse.com? Okay, so about half. So fantastic. So this is an online community that also acts as a repository. Who here's used GitHub or knows what that is? Yeah, okay. So it's GitHub for designs for physical objects, where people are open sourcing their designs. You can't just say, here's a picture of the thing that I made like you could on Instructables, but you have to say, here's the thing that I made and here's the file. You can download it yourself. They have lots of different ways for people to fork designs and then post and share and ask questions. It's very collaborative. People often, I like this example of people making pill holders and then even showing their failures, like it's too small, why didn't it work? And it's a community to help people do that. So for this research, this community had been around for a while and was really the place that people were getting started and people were talking about things that they were making. And it was really, really popular. And it had been several years since I'd been doing some of the thought work of what are the opportunities, studying abandonment rates. And so I had that question of, well, what's happening? Like the maker movement was at peak or close to it. And I wanted to know, like, well, how much of the stuff on Thingiverse is actually assistive technology? What kinds of assistive technology are people making it? Or what kind of are they making? And why are they doing it? So what we did was we did a systematic review of designs that were on Thingiverse.com. We came up with like a huge number of terms. So we had, I guess, 171 terms that then gave us like 25,000 things to sift through and figure out, all right, in our most generous definition of assistive technology, how many of those would we consider an assistive technology? Okay. Does anyone want to guess what percentage of things on Thingiverse might have been assistive technologies?
5%.
5%? Any other guesses? There's no prize. 70? Okay.
30%.
30%. Okay, I like those numbers. That was what I was thinking too. It turns out less than 1% were things when we gave like our most liberal definition of assistive technology could we classify as assistive tech. So at that time, Thingiverse had about 100,000 designs, and we were able to find like 363. And we spent a lot of time broadening our search. So here on the left, I have images of different categories of things that we found. And then on the right, the ranked list of the popularity. Actually, it's not the popularity, but it's just to match that diagram. So the most popular kind of assistive technology on Thingiverse was medication management tools, pill boxes, which are readily available at your 24-hour drugstore. So in terms of like how much of a need is there, these are not expensive things and you can buy them all over the place. Yet this was what we were seeing the most of people making. I expected there would be a lot of things like the wheelchair mounted cup rest, things from catalogs. And it's like, oh, great, now I don't have to spend $100. Hey, I figured out how to do this. Here you go. 6% of the things that we found fit into that category. There were really, really not many. And then I have some examples there of other things that people had. If you're interested in this, we wrote up a really nice summary of what we found. This is an analysis that we did of, okay, of those things, like who's interacting with it? Like I mentioned, Thingiverse has support for people to collaborate, for people to say, hey, thanks so much for that design, I made it, and post pictures of the thing they made for people to remix it. In the middle row, that shows the things that people were making. The most popular thing that anybody was making that was assistive technology was a spinner ring that had Braille on it. And again, if you think about like what are some of the challenges that people are facing and some of the problems with assistive technology use, I'm not convinced that Braille on a spinner ring is really like that high of like a priority for anybody. There were also a lot of things that people were doing around 3D printed hands, as you can see. So those were things that people were making a lot of. It was things that were being posted that people were liking. But not a thing that people were remixing. The bottom row is the, okay, I downloaded your version of it, and now I've put a new version. So the things on the left were things that had Braille on them. Somebody made a really great Braille library, so it was really easy to put Braille on objects if you were energetic. So we see the spinner ring, and then this little tactile globe. And then, of course, we see some of the pillboxes. So that was useful, but we still didn't really understand where the stuff was coming from and why. So we did an online survey. Of the 363 things, there were 273 designers, and so we emailed and contacted all of them, and we heard back from 69 of them to get them to participate in this online survey to understand why they had made this thing and put it up on Thingiverse, and to learn a little bit about them. And there were a lot of people who very altruistically and kindly were making this for somebody that they know. And I think in the paper, we break out exactly what that relationship was, if there's someone in their family or a friend of a friend. Only like less than half of that were people then who made it for themselves, which was really the target demographic that we were expecting. And I think it's interesting to note that the same number of people who are making assistive technologies for themselves was the same number of people who were like, well, I thought it would be a good way for me to practice my 3D modeling skills. People who saw this as a personal challenge. And then the numbers, the motivations go down from there. I don't have the numbers on the slide, but of these people, very few of them had any kind of assistive technology training or any kind of medical experience. For the most part, they were people who were engineers, who were already familiar with making digital fabrication, 3D modeling, and they wanted to try this out or apply their skills. So what does this all mean? Like, where is the state? Like, how can I answer Michael's great question? Well, the thing that is happening is we're seeing people start to make assistive technologies, maybe moving a little bit away from, okay, you can only get these things from these catalogs and through insurance, so people are getting them faster. We're seeing things that are definitely affordable, right? And we're starting to see some things that are customizable. The Library for Braille is a great example of the technology supporting customization. But I have this question, this lingering question of, well, is this empowering? Is this kind of fitting in with the larger goals of the maker movement and all of that marketing that gets us excited about making things for ourselves? Like, how is it different if someone is giving you this device and they made it versus if you buy it through the more traditional channels? And while I don't want to discourage people making things for other people, I think it's important to think about what is the sustainability of those things after they're made. Are people making things that maybe are not actually good for that person to use? A lot of people have been very critical of the 3D printed hand movement, both in terms of the number of people who have exactly that kind of limb loss is very, very small. But then a lot of the 3D printed things that people are making are really heavy. And so actually, for that limb, it can be really bad to use and would not be recommended. But because there was a Boy Scout troop or somebody who made it for you, that individual might feel obligated to use it and be putting themselves at risk. And I think it's really important to think about these issues as we're continuing to think about, well, what is the future of DIY and accessible making, and how do we not have it be a thing that then it's like, if you make your own object, you're going to be dropped from your insurance, which could be a real problem. And so what I want to transition to for the rest of the talk is the work where I'm thinking more broadly about, well, all right, how can we make making accessible to both end users and the experts and clinicians? And maybe we can move a little bit to having them be able to do it and build up a culture of kind of responsible making, and then we'll see this explosion that we were hoping for. Okay, so within this space, I've been focusing, I started thinking it was all about tools, and then I actually ended up switching gears and realizing it was more about training. So I'm going to go over just really briefly a couple of the tools that we had designed. And I think they're most useful to think about not in terms of, wow, these are technologically impressive digital fabrication design tools, but they're really, I think, carefully designed tools that fit in with this ecosystem and conveyed these ideas. So I'm going to talk about two of those, and then I'll talk about our work teaching this kind of stuff to physical therapists, and then also integrating it within special ed. All right, so the first one that we did was a project called VizTouch. Like several of you, when we're thinking about what cool stuff can we do for good and accessibility, when we're talking about digital fabrication, tactile graphics came up. And so for those who don't know, there's a long history of people making tactile graphics at home. And for a lot of both parents and teachers, hand make these because you can get them professionally made, but they're really expensive, they take forever, and it's often a lot faster. So we're working within a community and culture that already had a lot of DIY-ness around creating assistive technologies. So I love this example where you can make it out of glue and glitter. One innovation is to use puff paint to make tactile graphics, particularly numbers, or you can make tactile graphics using different kinds of embossing technology that ranges from a really, really inexpensive pen to really expensive machines. Within this space, we specifically focused on tactile graphics for math. We were working with some teachers and learned that in classrooms where students had a range of visual abilities, the blind kids got fewer examples than the sighted kids. And we heard a lot of stories of instructors who would stay up all night trying to make examples for their students with visual impairments, but they just would get tired, or there would be something and they needed an example on the fly and they weren't able to really keep up. So there was a real need for this. So we did something that was really relatively simple, where we created this really simple form-based interface, something that I think looks nothing like a 3D modeler or a creative tool, where you could just enter in information to automatically create this tactile graphic that you could upload like a spreadsheet, or you could enter in an equation and get a simple graph of it. So from this, which would take a few seconds to fill out, it would automatically generate a 3D model. So the 3D model could be generated in a minute that would then be ready for 3D printing. And the 3D printing of these things took about an hour, which, yes, is a long time. But again, if you're thinking about an instructor preparing materials for the next day, this is way better than staying up all night huffing like the glue or whatever it is. So this is much better. They can still do that on their leisure if they prefer. Yeah. So this is one example here. Showing like an equation, and then also kind of playing with what can you do with data. We were starting to think about, okay, what are the things that you can do with different heights too that you can do in 3D printing that's a lot harder to do in the manual things. We also learned that there was interest in playing with Braille. So for those of you who know a bit about Braille, there's actually an ISO for Braille in terms of the spacing and the size of letters. Now you can have it be whatever you want because some people have different kinds of sensitivity and actually cannot feel Braille. Also, Braille literacy, super low for people with vision impairments or who are blind. So people who are low vision actually wanted alphanumerics on there instead of Braille, or they even wanted to feel the letters and numbers. So it was a really flexible interface that we thought solved this very specific problem. Another example was, again, working with a school, but this was a very different, where we were working with physical therapists who were helping a student who wanted to use a stylus to access her iPad. So this school, like many schools, received a whole bunch of iPads, and they were trying to figure out what to do with them. And there was this access problem for this one student. The physical therapist had tried every grippy clay, spongy grip thing on the market, and none of them worked for the student's really unique hand contracture. So what we ended up doing was we went there and we gave the therapist some clay. They put the clay to get kind of an impression of that student's shape. We then 3D scanned the clay, and then from that we were able to 3D print it, poke a hole in, and put the stylus in. So we did this, and my grad student marched back in, really proud of herself, holding the stylus with the grip on it. She gave it to the therapist, and they said, well, that's never going to work. She has a different stylus that's bigger. And we're like, oh, right, oh man, we'd put in all this effort. And then we realized, oh, well, wait a minute. All we need to do is put a bigger hole in the grip. And so we did that, the new one fit, and now she's able to access her iPad. Hooray. But we realized there was this larger opportunity for, again, one of these really, really simple tools that we call GripFab. Again, simple form-based design where therapists can enter measurements. I've been really surprised and impressed. Some clinicians are very nervous about numbers and math, but they're amazing at taking measurements. And they can tell you to the millimeter or to the fraction of a degree exactly what something needs to be. And so interfaces like this, they're totally fine using. So we created many different versions that got more and more complicated. I think this was the final grip with the stylus, and then we wanted to have it at an angle so she could use it for eating and hold a fork and whatever else. And so we were really, really encouraged by this kind of stuff. So from that, we said, okay, well, maybe the clinicians as designers, how can we really empower them to adopt making? How can we really bake this into their practice? Led us to this work of working with clinicians. So the way we approached this was we were working with the University of Maryland, Baltimore's medical school, and they have an intro class to 3D printing. And they came to me and they said, we've heard a lot about making, and there's all this pressure to integrate fancy technology into our classroom. Can you help us? So what we did was we created a 3 or, depending on the semester, 3 or 4 class series where students would learn about 3D printing. The first class was demystifying 3D printing. For those of you who are more kind of like engineers, you're like, whatever. But if you're someone who's coming at this from a medical background, you might have a lot of ideas about what 3D printers can and cannot do, and you've never seen one. So demystifying that, we did exercises where they would create assistive technologies out of clay for imaginary patients as their homework. And then we took their clay away from them because that model worked really well. We went off and 3D scanned it, and then we brought back the finished designs, and we even let them iterate. So then they could hold the physical object and say, okay, no, actually there needs to be a hole here. This needs to be bigger. This needs to be smoother, or whatever kinds of modifications. And then we did that work. And so we're doing this for a 3rd time this semester. Just to give you a sense of kind of what we did, again, since these students were starting out and this fit in well with the things they were naturally doing in the class, the instructor created these different case studies where there were imaginary patients, where they had very clinical descriptions. And then for us, like HCI people, we needed layman terms to understand what the case was. And students would start by drawing. I was really encouraged to see these drawings that were significantly better than anything I can draw, that were very sophisticated and looked a lot like engineering drawings. This one is showing how a grip could fit on a cane to support limited wrist mobility. So we have a picture of the drawings, and then on the other side, the thing that's made out of clay that's red and green, and then we 3D scan that, and then a 3D printed version. Here's just a different version where they had a different case that was thinking about crutch grips and how you could support it. The green one was made out of clay. You can see the drawing. The green one was made out of clay, and then the black one was 3D printed. And for the most part, this is working. And we're continuing it, and we're actually now trying this with real patients. So they have an actual clinic, and so having the students come in and try and do this. And that's going on right now. So we don't have findings, but a lot of, I'll get to lessons learned from this, and we learned a lot from that. All right, the other activity that I wanted to hit on was things that we're doing in special education. We actually started this work by working with a high school that specifically serves students with cognitive impairments. We were working in their technology classroom. We gave them a 3D printer. We gave them lots of training. We gave them a grad student. We did everything we could, and we just weren't able to figure out ways to fit it into their curriculum. So we learned pretty quickly this was not gonna go very quickly. So what we ended up doing was we designed our own 3D printing class that we taught on our campus and it included students with intellectual disabilities. UMBC has a 4-year post-secondary experience program for students with intellectual disabilities where they take classes on campus. And so for the juniors, we created a 3D printing class for them. We taught this class 3 times. The amazing thing about teaching a class is then you have control. Every session is data about how people are learning and what's happening. And in this, they learned 3D printing, learned how to operate a 3D printer, and they learned a lot of 3D modeling tools. The thing that was unique about this class and the way the program was structured was every class was what they called integrated, which meant it was half traditional degree-seeking students and then half students from this program. And so what we did was we had these students learning this new kind of technology, learning these new skills, doing this design work together. And this actually became one of my PhD students' dissertation topics, is how do these really, really diverse groups learn together? I think there's a lot of opportunity because neither one of them had ever done 3D printing before. So nobody was the expert. Everybody was on the same playing field despite this huge difference in ability. And overall, it was really, really successful. Like I said, we've taught it 3 different times. The other thing and how we got people to take this class was it was a 3D printing for entrepreneurship class. So it was part of an entrepreneurship program. So again, it's like, here's this new technology. Here are all of these opportunities to change business and change things. So we had students designing things they could sell. We had them, there's this pile of rings that they 3D printed for like a client, and also did some of their own custom design work. And I think this aspect of incorporating entrepreneurship into accessibility is really important and really responsible when we were working with a population that has like a 60% unemployment rate. And so the students in this class learned these really advanced skills. They learned how to design, even if they never did anything with 3D printing. Again, a lot of these skills transfer to other kinds of work. And we've seen students from this program go into like data entry positions and other things, which is fantastic. Okay, so those are all the things that we did. What did we learn, right? The biggest thing, and I have some citations, and I probably could have put like every paper I've ever written. Time is the most expensive resource. And if you were to ask me, why are people not doing this? I would say it's either they don't have the time to do it, or they perceive that the amount of time it would take, they don't have. And this just came up time and time again, no pun intended. So for the example, we were doing the grips. I told that story in a way that made it sound like really efficient. That actually took months. And the reason was, even though the therapists were like, yes, we want this student to be able to access an iPad, that was not their top priority. They were working through, how do we help make sure that her hands aren't stiff? How do we address her communication aids? They had all these other priorities. Accessing the iPad was kind of in the nice to have. So we had lots of therapy, and also her therapy happened during school. So it was a 45-minute session where she had to be pulled out of her classroom, moved into another room, then she would actually get settled. And then we were like, okay, now we can do the thing. And I was like, no, we can't do the thing today. So just waiting for that took a really, really long time. And so the advice is to really understand the cycles of when this kind of work can happen. I think this also fits in like with the design tools. Like we designed things that really could be, the therapist or the instructor could be in and out in a minute, right? They weren't intimidating. They looked really quick. They understood it. It was already in the language that they were speaking and thinking, and that really reduced a lot of the barriers. Yeah, Michael?
Yeah, I'd love to unpack that
Yeah.
a little bit. Time is absolutely expensive, but people put in time for things that they see significant benefit from. So just thinking, I'm trying to align my mental model with this, and I'm trying to understand, is it something where the benefit is just not perceived to be sufficiently worth the time? So like, the front door in my house sort of is going to die soon. Like the lock is going to just stay locked, and we're going to have a problem. But like it's never like quite worth it for me to fix it. And is it and despite this being something they have to deal with all the time, is it just in that world where like I can muddle along and I'm doing other things? Or like
is it something?
Time is not itself the problem. It seems like it's some other pressure, other priorities?
There's a lot, so it's complicated. To that, and to really convince you that time is the priority, or time is a huge thing, and what's slightly different about the accessibility, and I would say even educational world, is that we're talking about people who, in their jobs, don't have time. Right, so especially if you're an education instructor, special ed, and you have your students and they have their IEPs. These are things that are priorities that are maybe even tied to insurance or resources that the school's getting, and these are the things that need to happen. And we see this in other educational environments too, where it's like math is the priority, and that's why we're having less time for art and music, right? And it's just like those are the priorities, and they're set by somebody else, and we need to do those things. And so that's very, very real. Also, there's the acceptance that kind of in the accessibility disability world, things just take longer. And so as a result, fewer things happen. And so then again, in addition to, okay, I have to learn all of these new skills, it's just like, you know, moving from this room to another room is really, really important, has to happen, but that's gonna take probably longer for some people than others, and there's all kinds of unknowns. So like you're working with a population that's already over constrained and taking time to do things. There's only so much time. But that's assuming you're trying to fit it into an educational environment. I think there's a real opportunity to fit it into other things that people are doing. How can you build it into recreation time or other sorts of things that people are doing that might be more flexible rather than straight therapy time, where you're billed by the minute. The other thing, of course, is there's already, like a lot of educators, a lot of therapists are overburdened in terms of additional things that they need to do because they care and they're passionate. And so then if it's like, okay, I need to learn some kind of like whole new technology thing that I've never done before, and maybe I'm not super confident with technology, that's just really, really a lot to ask. The other thing that I want to kind of comment on about time, and this fits into a totally different research project that I'm working on, is I think we also need to acknowledge that luxury time or time for like academic learning in that true sense, or tinkering time, is a kind of privilege. And so really thinking about who has that luxury to spend time to investigate, search out different kinds of printers, fiddle with the printer, all of that stuff. So it's really complicated. And we've seen it come across, like I said, in many different contexts. And I think it's really, really important to think that through in order to either get access or in order to have results to show. It's complicated. The other one is designing with familiar tools. We did not think that clay was going to be the thing, but oh my God, it's totally the thing. The things that people can do with clay that they cannot do in 3D modeling is impressive. Clay has a bunch of limitations, though, that you do need to consider. But for this application, clay is actually great because the same constraints of if you make something out of clay are kind of similar to the constraints of what is 3D printable. And so if you can make it out of clay and it can stand up, there's a good chance you'll be able to 3D print it. So without actually teaching them any of the physics of 3D printing, you can just relate it in this way that makes a lot of sense to people. Another piece of this that I wasn't expecting that really came out with the physical therapists is around identity and as non-engineers. And so if you take people who really identify as non-engineers and have maybe made a lot of choices to go to grad school in medicine rather than engineering, if you then ask them to do tasks they perceive as engineering, they'll often be self-defeating. And so how can you kind of trick them into do this or make it ways that are relatable to them where they're not going to be as intimidated? And a lot of this we also see in making with younger people, or how do we have inclusive like CS curriculums for girls. It's a lot of the same stuff, but it was something we weren't quite expecting with the physical therapists. The other is to anticipate a steep learning curve. I love this example as a 3D printed thing that I think this came from the class with the 2 students. And this was their, the assignment was make a house. And this is what they did. And for those of you who have any experience in 3D printing, you see all of the reasons that you can't just hit print and this won't work. Also, there's like some really complicated things about like, well, what is 3D? So this actually came from the physical therapy class where, the warm-up assignment was make a snowman. They were totally into it. These were younger people in medical school. These were the ones who weren't too intimidated by 3D modeling tools. And it looked great, and then you rotated it, and then you realized that they were designing in 2D. and not 3D. And so then you kind of have to ask yourself this question of, okay, how am I going to teach them what 3D is? How much time do I have to do that? Are they going to be resistant to that? How is that all going to work? Much with will it print, there's the whole question of will it scan? So people will make amazing things out of clay that are not easy to scan. So we've done some work where we're kind of showing what you can do with off-the-shelf, inexpensive 3D scanners, but we're also really lucky where we have access to Direct Dimensions, which is a professional 3D scanning company. And so when we have really exotic things, we're able to sometimes have them bail us out and scan that thing. But there are a lot of difficult technical challenges that you have to teach someone in order to design something that is 3D scannable. The other one is choosing the right equipment. So I love this story about why you can't just drop a 3D printer in a space and say, I'm done, I changed the world, and now everyone's going to be a maker. So this is a 3D printer that was at a school for the blind. And they got this donation. This was really expensive at the time, probably like a $20,000 printer. And they had the printer, and they had all the materials. The printer was stored in a closet, because it's an expensive thing. We don't want it to like walk out the door. And then on this printer bed, there's a photo of literally everything that had ever been printed on that 3D printer. Okay? So this thing was not getting a lot of use. There are a lot of reasons for that. Number one, this was I'll say just a powder printer, which means that if you drop it, it will shatter and turn into a pile of powder. And if you ever hang out with blind youth, you will quickly learn that things end up on the floor all the time, right? And so this is really bad, which is again why all the 3D printed objects were carefully tucked away in this closet that like only a specific person could access. The other problem with this, and part of the reason this printer is so expensive, it was a full color powder printer, which, wow, what an amazing, generous gift. But for the students who can't perceive color, completely useless, right? So again, there's a whole world of different kinds of these tools and thinking really hard about how do you match that up to your target population. The other one is size matters. An interesting thing we learned about the physical therapists was everything needed to be one-to-one scale. They made some really big things the first time we taught this class, and we were running short on time because our schedule was too aggressive and we didn't have the 3D print time. So we said, you know what, we'll just make smaller versions and they'll be able to like imagine it was the same size. So these are little shoes that could go on the end of like a crutch or a cane. And I swear, we brought it into the class and the students laughed at us. They were like, nobody could ever use that. Those are like doll shoes. Right? No, they had designed the thing, they had designed the giant doll shoe, and they thought that would be an assistive technology. But when we made it little, they were like, no, that will never, they couldn't imagine that translation. And so we quickly learned to set sizes for them in terms of how big of a thing we would make for them and make sure everything was always one-to-one. The other thing that we saw was that materials really mattered. Physical therapists that we were working with did not like anything with jagged edges or wasn't smooth. They loved everything that was a flexible filament. For those of you who've worked with flexible filament, it is difficult to print with. You have to print slower, there's more failure, it's really annoying. But we've just seen that's what they want and everything needs to be in that material. And so some of these tricks that we know about in terms of giving prototypes just did not work in this environment. We really had to have the one-to-one in the final version in order for them to imagine how they would use it and accept it. And then the other one is encouraging collaboration. We were amazingly surprised and encouraged at how successful the class was with these two really, really diverse groups working together and working in teams. We're doing this team-based learning a little bit in the 3D printing or the physical therapy class too, which I think is part of why it's successful is people are learning this new skill together. But I think there's a difference between two people learning together and more. There's a whole world of educational literature that could confirm that, but that's kind of what we're seeing here. This really works, and especially when nobody is the expert, they're learning together. People are more willing to accept each other's ideas. All right. So what's next? So there's a whole bunch of things to do. I'm continuously kind of studying what's happening in the DIY movement, what's happening in terms of assistive technology. Yes, that survey we did of Thingiverse was a few years ago. We haven't rerun it yet, but I'm pretty sure these fundamental challenges haven't changed yet. So but maybe I would love to be wrong. What I'm doing now is studying the impact of teaching these skills to non-engineers, so continuing with the physical therapists, ramping that up a little bit in terms of like what we can get them to do, both technically and in terms of thinking, and looking at what are the opportunities for maker employment. I started doing this in the class with students with intellectual disabilities, but I've recently started doing this with youth. So one of the new projects I did was open up a 3D print shop that employs youth in Baltimore that is part of an after-school makerspace. So this was a place where students would go and they would learn all kinds of cool 3D printing skills, programming skills, all this stuff. And they offer classes and activities for students up to the age of 18. But in Maryland, once you're 14, then you can go apply for a work permit. And so actually retaining teenagers in these kinds of academic after-school programs was really hard. So we've started creating and exploring, well, what are the jobs that people who've been through this can do? And so we have this print shop, and now this print shop is the one who builds and prints all the things that the therapists are designing. They're doing the 3D scanning, they're doing the 3D printing. So we're building up kind of this ecosystem where we're able to maybe have a more sustainable model of people who are doing the making, yet having the experts doing the designing. So that's the new thing that we're feeling out. Thank you so much for listening. I think we still have time for questions, so I'm happy to answer any you have. Thank you.
I was really interested at the 3D printed maps thing, that the tool that you showed. But it also seems to be limited in a certain number of ways.
Oh, a lot of ways.
Yeah. So I was wondering if you have any thoughts on how you can increase it, make it more scalable to teach more complicated maths or more complicated graphs even.
Yeah, so that's a great point, and it's a conversation I've been having with a few students here, is kind of making that decision of where you want to go once you have some of these ideas. There's a lot to be done there in terms of adding complexity, adding generalizability. You could imagine doing this for any kind of math. And I encourage everyone to do that. And I know some of the technologies you guys are developing are probably better at creating all kinds of tactile graphics than that specific one. We designed that to really solve that specific problem of, okay, here's a math class, here's an instructor who wants to do this thing. How can we make a tool that they'd be willing to use? What I wanted to do and just was never able to, because the collaborators I was working with are not at that school anymore, which really sucks, was to actually make a whole math book. Right, and so that way we could then have a whole curriculum and really test this out. And that's really the thing there that I think that work was missing before I would want to go scaling up the technology. We had done several kind of 1-2 hour interactions, some tests. Does this work? What do people think about this as a technology? But before I would want to add to the complexity of development, I would first want to do a feasibility test of this idea. There's a great debate, and I've had this with a lot of people, of should it be these hard plastic physical objects, or should it be some kind of dynamic display? There are good arguments for both, and before adding the technical complexity to this, I would first want to do that evaluation. And partly that's just my approach to research. But you're completely right that there are a lot more sophisticated things that we could do. But I would want validation from the teachers that this is even the right path. Yeah, but great question. Yes?
So when you started your talk with all the things on the Thingiverse, I was really excited about the potential of wow, I could get to that point where I can just find myself a cast and 3D print it, or an ergonomic cane or whatever. And yet, I think the work you did kind of didn't really go in that direction because, at the end of the day, once the therapist does their little thingy, none of that stuff is being shared online, right? It's still kind of a walled garden. It's still this old model. You're just using fancier technology to create the things. Do you think you could eventually transition to more a kind of more open, perhaps kind of bounty driven or something kind of way to direct the making of this, so that the end result is going to be accessible to everybody?
Yes, and I encourage everyone to create assistive technologies or create things and publish them and share them openly, contribute to these kinds of communities. The goal of my research and our research lab is to more understand how this technology might work rather than push any specific design. For a while, I thought maybe like, we'd be the tactile graphics team and we'd really lean into that. And again, making textbooks. But we realized because this is so new, there are so many other things that we don't know. We're also not an orthotics group where that's really not our strength as HCI researchers. So more we want to understand and empower other people to do that. I also skirted this, but something I could give a whole talk about of like, well, what are the liability issues if one of my students or I or somebody else makes something, puts it online, somebody else uses it, and something happens. And I think a lot of people are still figuring this out. We've done some interviews with physical therapists, and they have leaned more towards, well, if it's somebody who's a certified physical therapist and they make it, that's cool, and it's kind of then up, so long as it's then up to the end user to make that decision and the therapist if it's prescribed, but it's very, very complex. So that's part of why, too, the things that the students are doing in classes, we're not pushing them to be publishing. But these communities exist, and if anything, we're starting to see more and more people on Facebook and parents groups sharing that stuff. So I think that's happening organically because other people are like, yeah, I made this cast and I want to share it. In my research, I'm more interested in kind of like studying that or understanding what are the reasons other people aren't doing that naturally. It's a great question. Yeah.
So in your talk, you sort of presented this transition between you were starting working on developing tools and then moving into training. And it seems like there's probably a complex and interrelationship between tools and training, right?
Yeah.
But if you're somebody who wants to make an impact in DIY assistive technologies, do you have a sense or feeling of if there's sort of an equal opportunity or in the space of developing tools, or if training and facilitation, community building is sort of
all of it. Everybody needs all of it, right? Like, and even if you're thinking, if you outside of the space of accessibility, we still see lots of people who are not engaging in these activities, even though there's so many reasons to do this and there's so many opportunities. So I think there's always the opportunity for more tool development, more sophisticated tool development. We totally need that. Sometimes I relate this to cooking, right? Where I think of my kitchen as a makerspace, and lots of people have really sophisticated makerspaces in their homes, yet a lot of people still get takeout, right? And so if you think about, well, what is the real reason people aren't engaging in this? This also then in that metaphor goes to, there's always new tools that are coming out in the kitchen market that then get people who never had done it before to start cooking. So I think there's still a lot of space to do this, and there's value in all of them. And then I think it just kind of depends as researchers, kind of what impact do you want to have, what resources do you want to have. We're also seeing lots and lots of companies who are developing really cool and exciting tools. And so I think it's really exciting to see more and more of that happen. So there's so much space for that. And then as we have more of an ecosystem of those tools, then we can even start figuring out, like, what are those good for? Who's appropriating those tools? What populations? Are those tools accessible? How can we make them more? I'm starting to see some people looking at, what are the accessible 3D modeling tools for people with vision impairments. A lot of it has been text-based 3D modeling, and so then it's something that a screen reader can access. But there's lots of cool tangible things. I think some projects, even in this room, that are happening in that space. There's so much that can be done. And I think we're just still really, really early on in all of this. Yes, in the back.
Have you ever heard of Not Impossible Labs? And if so, what do you think of the work they're doing?
When do they what?
What do you think of the work they're doing?
I do not know much about them. Yeah. So I will go look them up, and then think about them before doing it. Yeah. There was also another hand in the back. Yeah.
Yeah, my father has a spinal cord injury, and I've kind of made some stuff for him, but really what stops me is that it's kind of exhausting to be in charge. It seems like there's all this institutional knowledge somewhere about what I should be making, what would help, that should come from the OT.
Yeah.
But they, as you said, just have a catalog.
Yeah.
And also don't really have time to say, well, let's custom build something that might work for this task that we don't know that you even want to do, because they don't really ask, they just kind of have a list.
Yeah.
I was wondering if you see that model changing at all, or how do you see that going?
It's a fantastic question. Part of the hope and part of the reason why I'm working with physical therapy instructors is to maybe be part of the next generation of people with that training who then also know about these tools and can build it into their practice or encourage other people too. I'm still not convinced, like until like billing changes, that physical therapists would be the ones to do that, but I could imagine they make the first pass at it, and then they give a tool like GripFab to the end user, or they give them the Tinkercad file, and then that person's able to do the customization. Or just even showing that it's possible, and as more people get to talk about it, see it, it becomes more common, then we see that culture develop. So I hope. But it's going to take time, just like other innovations. I mean, I think it is fascinating within some of these medical fields. Some of them leaps and bounds, lots of changes happening, other ones not, right? And I mean, that's part of just the structure of the medical system and liability and priorities, right? People might be much more focused on movement than activities of daily living or even leisure activities, even though that might be the thing that the individual really wants to have the most. I think it's also interesting that you brought up the issue of control and you feeling maybe unsure about having that much control. What I really see happening and kind of maybe the next kind of generation of this is that more end users are the designer, where we're seeing more of a participatory design approach, and then they're partnering with somebody else who maybe has some of the technical skills, or they're using a tool that is really accessible to them. And that way they can really be the ones driving it. So it's really complicated and interesting.
I have time for one more question.
Okay, yeah.
I have an 18-year-old son with a low vision, not legally blind, and I have found that the therapists are really resistant to anything that's not tried, true, and tested. And have you run against that? And have you found any way? The only people that are interested are the AT people, and they're just doing their little thing for fun. And therapists are like, no, thank you. Give me 20 years of research before I'll touch it.
Yeah, so that's real. And then I think it gets into some of the really interesting liability issues. So the most extreme version of that I've seen was working and talking with people with power wheelchairs. And again, it's like when it breaks, I stay in bed, and that was somebody whose power wheelchair is broken, and then they're just waiting for somebody to fix it. In some of my interviews and work, I've talked to people who are willing, so the end user is willing to go against what the therapists say and even violate their insurance or their warranty if they're involved in it, which I think is tremendously exciting, right? So like power wheelchairs are crazy expensive, like $50,000 pieces of equipment. You're really dependent on this, but there's, again, the consequences of not having it is so severe that people are like, yeah, well, if I can be involved and I can be making the decisions and I'm in control, then like, let's do it, let's solve it. That can also be a personality and a resource decision. So I don't think there's a clear answer. It kind of also depends about how we see more people taking control rather than just relying on consumerism, I think is probably what's going to dictate that attitude that you're seeing. Perhaps if we then have more medical professionals who are familiar with these tools, understand what some of the dangers and risks are, and have a better sense of what they are rather than thinking they're magical, complex engineering machines, then there might be more freedom. But it can also be really tied to personality and identity. So I hope so. Yeah.
All right, let's thank our speaker.
Thank you so much.